Okay, let's finish up our unit on graphing linear equations. We've talked about how to graph using a table. We've talked about direct variation. We've also talked about how to graph using finding the intercepts. And then we just got done talking about how to find slope. We're going to apply that information of how to find slope and use that, and we'll also take what we know about intercepts, help us graph linear equations. And we'll learn this equation here, y equals mx plus b, and also learn its significance. But first, let's take a look at our graphing calculator and see if we can learn what these m and b stand for. We already know m, if you remember, stands for slope. Okay, so we'll talk about what those mean for. Okay, so let's take a look at an equation, and the equation we want to take a look at here is y equals 2x plus 1. Okay, so in y equals 2x plus 1, we want to find some significant points. I'll graph it and we'll see if we can find the connections between some of those points as we start taking a look. So first thing we see here, in our equation y equals 2x plus 1, notice I've got this point here, 2x plus 1. I've listed two of the coordinates here, 0, 1, and 1, 3. If I look at the slope, it goes up 2. These are going by halves, these blocks, so 1, 2, over 1. Okay, so slope is 2, which is listed for us here. And then the y-intercept is another point we want to find. What's the y-intercept in this one? It's where it crosses the y-axis, 0, 1. So the y-intercept is 1. Okay, so the y-intercept is 0, 1, and the slope is 2. Okay, so keep that in mind, and now I'm just going to adjust the slope. Okay, let's get an equation where it's let's take a look now. So if I compare two different points, I got to get a new point here. Let's change that to 6. So now as I'm going from here to here, I'm going up 1, 2, 3, 4, 5 units over 1. And that means that my slope is now 5. So this m value we talked about is our slope. So this is going to give us our slope. And notice our y-intercept is still 1 in this graph. And if I change this value, notice what happens to our y-intercept. Okay. So if I change this value to 2, notice our y-intercept is 2. If I change the value to 5, it shifts the whole graph and it's 5. But notice, let me erase some of this. Notice our points. Okay, I've got a point here at 0, 5, and a point here at 1, 10. I can get its coordinates there. So 1, 10. So if its coordinates are 1, 10, and 0, 5, what would the slope be? Well, I'm going up 5 units over 1 unit, so it's still a slope of 5. So this b value, just you see what the b value does, it just shifts my graph. Okay, it just moves it up and down. The m value, notice what does the m value do? Shift this back down. It controls the steepness of the line, or the slope. So we can tell a lot about an equation if we have an equation, and if this is our equation, we'd say this equation is y equals 0.2x plus 0.1. And from that you could tell me, well, the m value is 0.2, so its slope is 0.2. So 2/10 would mean 2 rise over 10 run, so 1/5. So up 1 over 5. And then the b, this intercept is 0.1. Well, how do I know that's the intercept? Well, it's the y-intercept, remember? And the y-intercept, x is 0. So this, if I put 0 in for x, y is equal to 0.1. So we've already learned how to find that intercept. We've already learned how to find the slope. And this just gives us now a new equation to work with. And we call this slope-intercept form. So slope-intercept form gives us a lot of information. We know how steep the line will be and where it will cross the y-intercept. So if we have that information, here's where it's going to cross the y-intercept. And then the slope. Slope is true for every point on the line, so it's going to go up 2. And how do we write 2 as a ratio? Well, 2 divided by 1 equals 2. So the rise of 2, run of 1. And that's how we can create two convenient points. Just like we did when we were graphing using the intercepts, we can find two convenient points to create our line. So let's take a look at these examples. Identify slope and intercept. Slope is mx. So it's the constant of x. And b is the y-intercept. The y-intercept is -3. So 0, -3 is our coordinates for that. Now, this is in standard form. Okay, so if we want to find the slope and y-intercept, we need to change it and convert it into slope-intercept form or function form. So we need to get the y by itself. So in order to get y by itself, we subtract 3x. That leaves us with -3y equal to 12 minus 3x. And now to get the y by itself, I divide by -3. And I get y equal to 12 divided by -3 is -4. -3 divided by -3 is a positive 1x. So now my slope, once it's in slope-intercept form, it's the coefficient of x, so 1. My y-intercept, I put 0 in for x, y equals -4. So 0 for x, y is -4. Okay, and we see how we can use that to find our, talk about our graph. We'll do that in the next slide. But why don't you try this one? See if you can find the slope and intercept. Pause it and start it when you're ready. Okay, so we need to get the y by itself. So we subtract x from both sides. We get -x and positive 6. So 4y equals -x plus 6. Divide both sides by 4. So -1/4 x, or -1x over 4, plus 6 divided by 4, which I can simplify as 3/2. So my slope is -1/4. My b, my intercept, my y-intercept is, I put 0 in for x, and the y would be 3/2. So 0 and 3/2. Okay. Now, let's apply that one step further and graph using slope-intercept form. So if I know the slope and the y-intercept, how do I make a graph? So let's first begin. What's the y-intercept, or the b? -3. What's my slope? Coefficient of x, 2/3. So I found my m and my b. And where do we start? Well, the y-intercept is at 0, -3. So remember those coordinates, 0, -3, x is 0, y is -3. That's my starting point. And then what's my slope? From here, I rise 2 and run 3. And that's how I can find two convenient points. The next one, my slope, coefficient of x is a negative. That's a -1 because -1 times x is -x. Y-intercept, put 0 in for x. I get -3. So my coordinate is 0, -3. That's my starting point. My intercept, slope of -1. As a ratio, that's -1 divided by 1 is still -1. So down 1 over 1. And mistake some people make is they see a negative and they automatically assume they go to the left. This negative deals with our rise, so go down and then run to the right. So why don't you try the next two examples. Pause it and start it when you're ready. Okay, so y-intercept of 0, 5. Slope of -5 over 2, so down 5 over 2. Keep in mind, if I wanted to go left, I would have to reverse. So instead of, if it says rise is -5, so I'd have to go up 5 units and then left 2. Notice that stays in line with what we're working with. So just understand your concept of slope and you'll be fine. The next one, y-intercept is 0, -4. Slope of 5. 5 over 1 because 5 divided by 1 is 5. So start at 0, -4 because that's our y-intercept. Slope of up 5 over 1. Try to draw straighter lines than I do. Okay, how would you graph this equation? Remember, we could start with the table, x, y. Well, let's start with 0. Let's create another point. 1. Let's create another one. 2, 3. Okay, if I put 0 into the equation, 2/3 times 0 is 0. Minus 5 is -5. I could have found that by looking at the intercept. 1, 2, 3, 4, 5. Finding my y-intercept. 0, -5. If I don't know that the slope is 2/3, or if I don't remember what the slope means, I just go back to my table. Well, 2/3 times 1 is 2/3. Minus 5 is -4. And 1/3. 2 times 2/3 is 4/3, or 1 1/3. Minus 3, -3 2/3. 2/3 times 3 is 2. Minus 5 is -3. So I could plot all those points. 1, -4 1/3 is roughly here. 2, -1, 2, 3 2/3 is about here. 3, -3. Okay, or I find my slope, I find my intercept. 0, -5 is my y-intercept. My slope of 2/3, up 2 over 1, 2, 3, finds the other point. And I can plot that quickly and efficiently. So slope is 6. Intercept 0, -3. I can graph that at -3. Slope of 6 over 1. So you can kind of see how this is a shortcut. Well, it's really a curvy line. And this shortcut helps you because, if it's in slope-intercept form, we don't have to go through the process of creating the table and doing all the calculations and evaluating each point. We can quickly just find the y-intercept and the slope. But keep in mind, if you forget some of that, just go back to what you know about creating a table. It'll work either way. In this case, I can't just say, well, the slope is 6 and the y-intercept is -3 because it's not in slope-intercept form, function form. The y is not by itself. I'd have to divide by 3 first of all. So I'd have y equal to 6x divided by 3 is 2x. -3 divided by 3 is -1. So my y-intercept would be -1, 0, -1, slope of 2. Okay, so keep that in mind. If you're going to use slope-intercept form, find the slope and intercept. It's got to be, y has got to be by itself. Is this one in slope-intercept form? Not yet. You have to subtract 2 first of all. So y, put it over here, y equals x minus 6. So the y-intercept is at 0, -6. Slope of, well, there's no coefficient of x. Sure there is. It's 1x. 1 times x is x, so up 1 over 1. If I want, I can just continue going up 1 over 1 until I feel like I got enough points. Might help me draw a straighter line too. Okay. All right, this one's in standard form. If I want to get it in slope-intercept form, I would subtract the 2y. No, I want to get y by itself. Subtract 4x. Leaves me with 2y equals 0 minus 4x. And 0 minus 4x is -4x, so I've got 2y equals -4x. And then divide by 2. So y equals -2x. In this case, what's your y-intercept? Well, if I put 0 in for x, -2 times 0 is 0. So my y-intercept is 0, 0. And then my slope is -2. Not a very good negative sign. So down 2 over 1. All right, let's take a look at kind of how we can model a real-world situation. Okay, so in this case, your family goes to a hockey game. They spend $60 in tickets and $4 per parking. $4 is the rate of change. It's how much it's changing per hour. And 60 is your starting point, or the initial value. In that case, would be our intercept. So we're starting at $60 no matter what before we get there to buy the tickets, and then it's $4 every hour after that. So after 1 hour, we're up to $64. After 2 hours, we're up to 68. After 3, we're up to 72. 4, we're up to 76. 5, we're up to $80. So we can graph that. It says suppose the parking fees raise to $5.50 an hour. So our slope or our rate of change is different. It's going up more. And so we're still starting at $60. But now in this case, we're going up. So after 1 hour, it'd be up to $5.50. So up $5.50 over 1. So $65.50 to $71. $76.50. And add another 5. $82. So notice this one just increases a little bit quicker. Okay, so let's take a look at certain equations and what we can tell from them. So let's take the equation y equals 3x plus 4. Y-intercept of 4, slope of 3. Graph that, that's what it looks like. Y equals 3x minus 2. Intercept of negative 2, slope of 3. Y equals 3x minus 4. Intercept of 0, negative 4, slope of 3. What do we notice about these three lines? Is that they never cross. We refer to these as parallel lines. They have the same slope. Lines are parallel. So what do you think will happen when I take a look at y equals half x minus 3 and y equals half x plus 2? Are you right? They're parallel. They don't cross. This one starts at negative 0, negative 3. This one starts at 0, 2. But they both go up 1 over 2. How about the next equation? Y equals 4 minus 5x and y equals 4 plus 2x. What do you notice is the same about those? They both have 4. That stands for their y-intercept. Okay, they both cross at 0, 4. But this one has a slope of negative 5 over 1. This one has a slope of 2 over 1. So they meet at a point because their slopes are different. And finally, we have 4y minus 6x equals 8, and 3x minus 2y equals 6. Notice what happens when I graph those two lines. Those lines are parallel. Why? Well, those are in standard form right now. If I were to get those into slope-intercept form, I would find that they have the same slopes. So I need to compare them by getting them into slope-intercept form. So what we can take a look at here is that, put down our notes that parallel lines never cross, okay, or never intersect. And they have the same slope. So I can take a look at equations and tell if they're parallel just by looking at the way they're written. So I can look at this graph and this one. Are they parallel lines? Well, this one's slope is 8. This one, I don't know the slope yet. I have to subtract 8x from both sides to get y by itself, so it's in slope-intercept form. And I see y equals 3 minus 8x, or negative 8x plus 3. This one has a slope of negative 8. So these are not parallel. Okay. Let's look at the next two sets of equations. Y equals negative 3/5 x plus 2. That one's in slope-intercept form. Its slope is negative 3/5. And the next one is in standard form, so let's solve it for y. Subtract 6x. We're left with 10y equals negative 4 minus 6x. And then we divide by 10. So we get y equal to negative 4/10 or negative 2/5 minus 6/10 or minus 3/5 x. And I see that slope is negative 3/5. So I'd say yes, these two are parallel. So without even having a graph, we can tell they're parallel just by manipulating the equations algebraically. And finally, let's take a look at this problem on the bottom. In Pennsylvania, they changed their maximum speed limit. The diagram shows distance d in miles a person can travel driving at the minimum speed limit of t hours before and after 1995. Before, distance was 55 miles per hour. after his distance is 65 miles per hour. If we graph both equations on the same coordinate plane, 0 hours, 55 miles, 110, after 2, and let's put the other one up there. Distance is 65, so 65 after 2 hours would be 130. So if we graph that one, find the differences using the graph. A person could drive in 3 hours before and after the speed limits change. So we go up to 3 hours, and we look here on this one, and this one here is after 3 hours, 65, 130, 195, and this one, my graph isn't very good. I should have drawn my points in better. And the other one, if we go 55, 110, 165 after 3 hours, we see that it's a difference of 30 miles, which adds up after a while. So from using a graph, we can compare and contrast differences there. So we've learned what parallel lines are. They have the same slope, and we've learned a shortcut for graphing now. We learned how to use the slope-intercept form by finding, well, the intercept is a value by itself, the b value, and when we plug in 0 for x, that gives us our intercept, and the slope is the coefficient of x that helps find a second point after that.